this is our MU100 project. It's basically like a bike thief violator. We have this circuit box mounted up to my bike, and if you take a look inside the circuit box, you have the ESP32, we have our accelerometer, and our motor driver. Now, all this is sitting on top of a 12-volt battery pack. It's the black thing underneath. You can see the switch, which we made externally accessible right here. And what this controls is basically a linear actuator. It's a shaft parallel attached to the seat shaft. And when actuated, the shaft will come out and, harass your bike thief.
So what we have here is our housing for our project. This first part, both of these parts that we 3D printed are made out of PETG. This one, rectangular housing, is for both our battery and our circuit board. And the reason why we have it strapped to the front is that it's easily connected to our other housing right here, which is for our linear actuator. Our linear actuator, in this case for our project, is the thing that we're computing through our accelerometer. So once it detects a certain amount of acceleration on 2 different trials, then it will activate, and we can activate that through our power from our battery pack inside of this rectangular housing. The reason why we have this housing in this way for our hardware is that it's rotationally constrained. So even after there's force being constrained from the top of the pin, from the linear actuator, from the person that's sitting on the seat, it's not going to fall off the seat in any way. So yeah, that's the reason why we have it in this order. And yeah, that's our hardware.
So we're doing a live demo right now. I'm gonna pop the lid off so you can see what's going on in here. First things first, make sure you switch on the 12-volt battery pack, otherwise the actuator will not come out. Second thing is, on the ESP, there's that red LED. If that is on, that means we are connected to some kind of Wi-Fi network and we're ready to run. So in running configuration, basically the accelerometer will start looking for acceleration past a certain threshold. Now this threshold was kind of set arbitrarily, but it's what we estimated a bike thief would jostle a bike at. So the catch though is the first jostle does nothing, because sometimes your bike just tips over or somebody else is trying to get a bike adjacent to yours. But after about 5 seconds or so, if jostles within past that threshold are sensed again, then the actuator starts coming up, and it'll just run an infinite loop up in and out of the seat. And then when you want it to stop, once it's all the way in, you just press the reset button on the ESP or just flip the switch off.
So the system that we used to connect us to the internet, or I guess for this project to be relative to the internet for us and for it to be practical for our use, is Adafruit and through the IFTTT program, IFTTT. So what we're going to be doing is basically is after the shaft is activated, as you can see it is activated as we speak, the circuit that we have and the code that we have relates it to the Adafruit server, which will send it to the IFTTT applet. What that will do is send us an email as soon as the shaft is moving, and we actually have an email here because of this project that is immediately sent saying that someone is stealing my bike. So yeah, after we get that email, we can run from our class, come over to our bike and see the thief struggling to get out with our bike. Yeah.